Welcome to lesson 13, where we will be looking at the definition of scientific notation. We're going to use scientific notation to describe large and small numbers. To be successful at this lesson, you'll be able to tell whether or not a number is written in scientific notation. We start with a number talk multiplying by powers of 10. You have 4 different expressions written here. Your goal is to find the value of each expression mentally. Try not to calculate anything using any other means other than mental math. Pause here to go ahead and give that a try. Okay, let's discuss some strategies for these. This first one can be thought about as 123 times 10 to the 4th. This puts 4 more decimal places to the left of the decimal point. If I were to write this out, it would look like this, 1,230,000. So you see underlined there are the 4 more decimal places that are to the left of the decimal point. If we use this same kind of strategy, this next one would put 3 more decimal places left of the decimal point. That would look like this. In the next one, this would put 2 more decimal places to the left of the decimal point. So it would look like this. And again, those underlined pieces are the decimal places to the left of the decimal point. This last one is actually going to put 2 more decimal places to the right of the decimal point. So that would be the expression or the value of that expression. Okay, keep this in mind because this is going to play a role later in the lesson. We move into the science of scientific notation. So earlier in lesson 10, we examined the speed of light through different materials. We zoomed in on the number line to focus on the interval between 2 times 10 to the 8th meters per second and 3 times 10 to the 8th meters per second, which is shown in the figure here. We saw that the speed of light through ice was 2.3 times 10 to the 8th meters per second. This way of writing the number is called scientific notation. Scientific notation is useful for understanding very large and very small numbers. A number is said to be in scientific notation when it is written as a product of 2 factors. So here are the 2 components that you need to have for scientific notation. The first factor is a number greater than or equal to 1 but less than 10. So for example, 1.2, 8, 6.35, or 2.008. That's your first factor. The second factor is an integer power of 10. So for example, 10 to the 8th, 10 to the negative 4th, 10 to the 22nd. So if we go back to that situation, the speed of light through ice was written as 2.3 times 10 to the 8th, we would call that scientific notation because that first factor is greater than or equal to 1, the 2.3, and it's less than 10. And the second factor is an integer power of 10, 10 to the 8th. As you move through this first activity, you're given a table, again with all of those materials that are listed and their speeds. You're going to circle the speeds that are written in scientific notation. The ones that are not written in scientific notation, you're going to rewrite so that they are in scientific notation. Pause the video here and try this on your own before we go through it together. Okay, so in this table, there's actually only 2 materials that are written in scientific notation. The first one is water, because that first factor is 2.25. It's greater than or equal to 1, but less than 10. And ice, whose first leading factor is also greater than or equal to 1 and less than 10. And both of their second factors are integer powers of 10. Which means the remaining materials are not written in scientific notation. So we're going to go ahead and convert those. The first one is space. And so looking at that, I have to again think about that leading factor being greater than or equal to 1, but less than 10, which tells me it's going to have to be 3. So I'm going to rewrite this as 3 times 10 to the 8th. That would be equivalent to 300 million. For copper, looking at that, I know my leading factor would have to be 2.8. So I would write this as 2.8 times 10 to the 8th power. For diamond, my leading factor would have to be 1.24, greater than or equal to 1, but less than 10, and the second factor is 10 to the 8th. And for olive oil, the reason why this is not written in scientific notation is, again, that leading factor has to be greater than or equal to 1. Olive oil is currently written where the leading factor is less than 1. So we have to change that to 2 times 10 to the 8th. Almost all books and information about scientific notation use the multiplication symbol as an X opposed to the dot. So you're going to start to see things being written as this 2.8 times 10 to the 8th using that X symbol instead of the dot. That's just more of a common way that scientific notation is written. So from now on, you will see that symbol being used. So in the situation of 124 times 10 to the 6th, how must we write the first factor for the expression to be in scientific notation? So let's just break this down step by step. We would need to make sure it's a number between 1 and 10. In this case, it would have to be 1.24. So again, now looking at the 124, how would we write that as an expression that has 1.24? Well, we would have to think about that as 1.24 times 100, or 1.24 times 10 to the power of 2. Oops, sorry, didn't mean to go too fast there. So now we have to think about that all together. So we now have an equivalent expression in scientific notation. We would have the bolded 124 be rewritten as 1.24 times 10 squared, still multiplying it by 10 to the 6th, which gives you 1.24 times 10 to the 8th, and that would be written in scientific notation. How would we write a very small number, which looks like this, in scientific notation? So again, thinking about what is that leading factor. In this case, it's going to be 2.1, but we're not going to be multiplying by 10 here. This time we'll be multiplying by 1/10, so we're going to have a negative exponent. So this is 2.1 times 10 to the negative 5th. If we have something like this, here we would be multiplying by 10, and we would be doing that 7 times, and the leading factor is 2.1. And so that is a representation in scientific notation. Read through that lesson summary if you choose. Otherwise, you're successful if you're able to tell whether or not a number is written in scientific notation.